I went there watching your first video. It doesn't have audio.
What?
Sam, you're a stalker. Why do you watch it first?
I went there watching your first video that you did. It doesn't have audio.
Yeah, I know.
Do any of them have
Why
audio?
do you
Yes.
Why do you need audio when you can just look at
They do have audio. Okay.
Why were you watching the first video?
I don't know why he was either. All right. Now, remember, you guys already know how to add and subtract. Okay? Of course you do. But that isn't the same as, or wait, I shouldn't say that. You know what to do, but that's not necessarily the same as understanding it. Yes? So, we're going to make sure we go over this a little bit. Make sure everyone's on the same page, and then we will carry on. Now, obviously, the first part is very simple because we are going to use pictures to make it happen.
Yes.
Right? But then we're going to go on to doing other stuff.
Cool stuff.
So, just like I did before, I want you guys to be aware of the number line because it is so fundamental to higher level math to actually understand what is going on. For example, I have helped you out with this one to show you. This says negative 2.3 plus negative 1.9. Now, what does that mean in English? What does that mean is happening on our number line? Where do I start?
Yeah.
Okay, so this means I start at negative 2.3, which is left or right of 0? Left. And what does the plus mean? In English, it means the next thing I do. Then I go left again, how far? 1.9. Now, the problem is, every number line can be divided differently, yes?
Yes.
And every number line, even though it's divided into parts, can be used for any adding and subtracting as long as you know how numbers work, right? That's the problem. Could we, in this number line, which is divided into 10 spots, so which is each one, how much is each one worth? 0.1, yes? So even though these are all worth 0.1, could we use this number line to subtract halves? Yes, as long as I'm aware of how to convert, right? Okay, so we start at 2.3, which I have put on here, and then we go left 1.9. Well, how many steps is that on here? 19. Are we really going to count 19 steps? Of course not. What is a shortcut you could use here? Wholes, right? I can go down to 3.3, 4.3, but I don't need to go 4.3. Then I can go back 1. And what is the answer?
4.2.
Negative 4.2. Now, many of you can do that in your head. Yes, I know that. I'm well aware of that. The point of the number lines is to show you a few strategies that will help. Because a great many of you, not you guys, but a great many of the grade 9s I teach would actually sit here and go 1, 2, 3, 4, 5, until they got up to 19. Do you understand what I'm saying?
Yes.
Is it going to get them the right answer?
Yes.
Do we care that they do it that way?
No.
Of course not. But we want to do our math efficiently. Because we know that this is the basis for the next 4 years for you guys where the math questions take a page to answer. Understand? And the problem, the major difference, hold it in your head, the major difference between you guys and those guys is they see this as the end of their math journey. And this stresses them out. Whereas you guys see this as the beginning of your math journey and you learn this automatically. So you're not wasting RAM trying to add stuff when you're doing super high-end math in 3 years. You're not wasting brain power. Oh my God, I can't remember how to add decimals. So I'm going on a calculator. And of course, how many of you have ever hit the wrong button sending a text? All of you put your hands up. And how many of you have ever hit the wrong button on a calculator? All of you put your hands up. And how many of you then believe the answer the calculator gave you, write it down, and then get the answer wrong on a test? All of you put your hands up. Never?
Never used a calculator.
You got...
No, like in exams and like assignments. I'm not kidding. Honestly,
Okay.
totally.
Okay. The point I'm trying to make is if you actually know what you're doing, it is very helpful when it comes time to do more serious questions where you are going to be using calculators. Do you understand what I'm saying? How would I do this, do you think? If I wasn't allowed to use a calculator and I was bad with numbers, what would I do here? I would estimate first. And what would I estimate, do you think? What's that close to? -2. What's that close to? -2. So my answer must be approximately -4. And is it? Yes. Now, if this were a big, long bunch of numbers to add up, and you would use a calculator on a long bunch of numbers, could you save yourself a bit of time by just estimating 4, 8, 17, so on? And okay, my answer's got to be close to 18. Do the math, the answer's 17.3. Are you happy? Yes. Now, a big mistake, huge difference between a pre-diploma student and a regular student is the pre-diploma student refuses to do that estimating. They refuse to find an answer, to guess at an answer that might be right. And then they do a half page of work. They get an answer that couldn't possibly be right, but they write it down. The calculator said so. Okay? Math teachers hate that because your calculator only does what you tell it to do. Picking up what I'm putting down? So what's the key? Estimate, estimate, estimate. So let's look at this. What is this number close to? This one. Oh, I forget. My old computer, wherever the pen was, it put a big purple circle on the screen so you could see it. I got to find an app that'll do that because the old app I had doesn't work with Windows 10. So, yeah. So I got to find a new app that will light up the cursor. I will find one, I promise. So anyway, this number right here, what would you estimate that as?
0.5.
You could do 0.5, but then you're stuck with decimals again, right?
1.
I would call that -1. And what do you call this? Well, we're just estimating again.
Well, like, if you change 1.
That's -1 again, right? So our estimate answer, and I'm going to use this symbol, which means approximately, -2. Are we happy with that? Yes. Now, you can see on the number line, I've already put the dots there, because I didn't want, I wanted you guys to see how to do it. Go to -1/2. Now, I got to add 5/4. What does my number line cut into? 4ths. 1, 2, 3, 4, 5. And there's my answer. Is -1 3/4 close to -2? So do I have the right answer? Easy peasy lemon squeezy, right? That is the right answer. Yep. Now you guys do these 3. Go.
Matt, do you have to use a number line?
On this, yes. Because part of the, whatchamacallit?
Being smart?
No. Part of the, not curriculum, the curriculum is what we actually do. Part of the learning outcomes, what you're supposed to know by the end of the 9th grade, is not only how to add it, but how to show it, to prove it. And as you get further and further along, Amshman, you're going to have to prove everything you do. Like in grade 12, not grade 12, at university, 1 + 1 = 2 isn't good enough. It takes like pages of math to officially prove that 1 + 1 is 2. You want me to talk about pages of math, or you want to do grade 9 math?
I want to do pages. I don't like number lines.
We'll be done with them soon.
Matt.
Yeah, of course we're not going to do number lines very long. I just have to make sure that everybody knows how they work. And of course you all do. I'm doubling it up by suggesting you also estimate approximately negative 3. Then we'll go one back. 1, 2. Is that right? 20. Oh, I didn't go far enough. Dummy. Why did I do an estimate there?
So you can be smart and have an idea of what you're
Have an idea what your answer's going to be. But somebody always says here, is this a good estimate? It's not so hot, is it? Because negative 3 and 2.2, you would never round 2.2 to 3, would you?
No.
So then we take a second and we think about it. Well, obviously it wasn't negative 5. I got to shift a little. It's not exact, but the estimate helps. Cool? All right. Negative 1/3, which I'm going to call 0, plus negative, what's that close to? Negative 2. So my answer is approximately negative 2. It's the estimate. Negative 1/3. And I'm split into thirds. So I got to go down 7 more. 1, 2, 3, 4, 5, 6, 7. There it is right there. Negative 7/3. And my answer is negative 2 and 2/3. Cool? Everybody good?
Yeah.
Because believe it or not, there is more to adding and subtracting than just adding and subtracting. Now, what's weird about C? Why is C different than what we've already done? Jack.
Because it's starting, like the first number isn't a negative.
No.
That's a difference.
Yeah.
That's cool. So we're going to have to be going over 0, aren't we?
Yeah.
Excellent. Josiah. The denominators aren't the same. And to make things even worse, how is our number line set up? 1, 2, 3, 4, 5, 6, 7, 8, isn't it? Right? So here's a mistake a lot of kids make. They see that many dots, they automatically think it's decimals. Is it decimals? No, because what are decimals split into? Tens. So that's no good. But Jack, what were you going to say?
Kind of what you
No, go ahead.
Well, you could like double the negative 4.
Yeah, you're doing the next thing. Which, if you look on your notes, is the very next thing we're going to do. Adding fractions that have different denominators. Which you all know how to do, but we're going to remind you anyway. So, Jack says, I got to change my common denominators. Which is wonderful. That's what we would really do. Those are the steps we would take. But that's not the math that we are performing. Does everybody understand the difference? Right? Okay. For example, I could tell you all right now, drive to the mall. Could any of you do it?
Yeah, but no. Yeah,
Some of you know how to drive a car right now, maybe. I agree. I'm betting most of you don't. Now let me add a wrinkle to it. My car is a standard. How many of you, if you don't know how to drive, but know how to drive a standard? Oh, what? Exactly. There's a joke going around on Facebook for old people like me. Millennial anti-theft device. And they show a picture of a gear shift and a clutch. Because nobody knows how to do it.
Yeah.
Right? What?
A kid like our age, he drove to Surrey and like when he was like our age, and he got arrested.
Good.
And then he got his driver's license suspended.
Good.
When he was 21.
Good.
There was a 6-year-old in like the States who was driving like a big straw around.
Yes. All right. So, now, guys, you all know to make this common denominator, but how are you able to prove this?
With math.
So where do I got to start? 3/8. 1, 2, 3. There's my 3/8. Right?
My answer is no.
Now I got to go negative 3/4. But then I got to know eighths. How many eighths are in a quarter? 2. So I got to go 1, 2, 3. And what's that? Negative 3. 1, 2, 3. What is it? 3/8. Does that make any degree of sense?
No.
I guess I can use denominator.
Yeah, because if you change the denominator, it's -6.
Yes. So this, if you change the denominator, becomes negative 6/8, right? 1, 2, 3, 4, 5, 6. Still negative 3/8. Oh. Is everybody good? This is what you are actually doing. What you were taught in grade 4 and 5 when you first learned fractions is a method of doing it. Okay? Understand the difference. There is a very big difference between what you are doing mathematically and how you do it. Do you understand? Anybody can learn steps, but if you don't know what you're doing, then as soon as the thing you need to solve is slightly different from the steps you know, you're going to be screwed. Do you understand?
Yeah.
Sam?
Last year, I was in 2 for 9 years.
Yeah?
Like I quit last year.
Yeah?
And I wasn't really, I was doing a lot of math.
Yeah?
They wouldn't like teach you like how to do it, like they wouldn't explain like what we do, they just tell you how to do it.
Yeah.
And then like when I got onto the new unit in the work, I couldn't do it.
Yeah.
So like my mom got me out of it.
Yeah. Because all those programs will teach you exactly what you need to do. Do this, then this, then this, then this, then this, which will get you through a certain amount of math. But once it's slightly off that path, you're screwed, right? I spend so much time trying to make you guys see what it is you're doing so you can apply it to every situation. Understand the difference? All right. Now, obviously, this one, we already know what to do. Now, Amshuman is very happy because there's a word in this that he is very happy to see. What is that word? No, without the number line. Now we do what you guys are all comfortable with. What's that? Math! Or what you think is math. Right? Which what you guys know of as math is following a series of steps to get an answer, yes? That's what you're comfortable with because that's the way we in Canada teach math. And it's not the best way to teach it, but it's what we got. So you guys already know how to do this. This will not work, right? Who can explain to me why this doesn't work? Without using the words, they don't have the same denominator. Who can explain why we cannot do that? And you're not allowed to say a word about the denominator. Sam. Okay, why? But I'm asking you what you mean by that. If I get a pizza and I cut it into 5 slices to share with you, Josiah, Paul, Evelyn, and me, could we do that? Could we cut it into pieces and share it? Would you know how much you got? Would I? Sure. So halves and fifths do work, right? If you and Paul and Evelyn all eat a piece of pizza, how much is left over for me and Josiah? 2/5. But that's not a half, is it? So halves and fifths do work together. You can plainly see they're not the same. But they work together. What do you got?
Isn't it about the math? Do you wear the same thing for picture day every year?
Yes, that's why I'm wearing this shirt. This shirt is 21 years old. I can only wear it 1 day a year because I don't want it to fall apart. Yes, we've had this discussion.
No, we haven't.
On the far left, I'm in the 10th grade. I have no girlfriend, so I'm happy. On the next one, I'm in the 12th grade. I look like my grandmother has been run over by my mother, who was then caught in a fire set by my father, and my dog peed on the fire afterwards. That's how sad I look. Why? Because I have a girlfriend. No offense, girls. And then teacher. Now, you can see the first teacher picture there. I'm wearing a white striped shirt and a Looney Tunes tie. 1 year later, completely accidentally, I'm wearing the exact same shirt and a Flintstones tie. The third picture there, again, completely accidentally, I'm wearing the exact same shirt and the same tie. So accidentally. So once it happened by accident, I had to make it start happening on purpose. The fourth picture there, I remembered and I did it right. The fifth picture there, I forgot, and I had to get a retake with the right shirt and tie. And then I'm back on board. So today was picture day, so I have the picture taken with the right shirt and tie. And eventually, I will be retiring in 2032. So 2016 will be on there, and then there'll be 16 more of those pictures. And they will all be in the exact same shirt and tie. And by the time I retire, the shirt will be 50 years old. So hopefully it will hold together. If not, I will have to cheat and find another shirt that looks like this. I do have one that's very similar, but it's short-sleeved. So I will have to, some of those, it wouldn't work. They took enough picture of my body that you could see it was a short sleeve. So I don't know what I'm going to do yet. But I'm not worried about it because it's a long time from now. This shirt has not actually physically fallen apart yet, so I'm okay. I've been debating getting one of those bags you can suck all the air out of with a vacuum so it lives sealed all year until I need it the one day I need it. And then I'll put it back in another bag and seal it. Only for picture day because it's 22 years old. It's gross. Like it's all frayed and I don't like it. But I need to keep continuity all the way. This tie is 18 years old. It's getting a little gross too, and I don't know what I'm going to do with that because you can't wash ties. I scrub it by hand, but I might have to take it to the dry cleaner, but it's getting frayed. I don't know what's going to happen. It would have to be the same tie. I've never seen this tie. Maybe. So, where was I? Sam. 5s don't work with 2s. But they do because you would know what a half a pie looks like. But you're on the right track. Jack took us completely off the wrong track, but that's okay. That happens. I am aware of how the grade 9 brain works. So I'm going to bring us back onto the regular track and say, can anybody else tell me why this doesn't work? Why? Sam. That, now you're again getting warmer. We have to split something. Okay? So what if I have this? It's not equal, but it's close enough, yeah?
Yeah.
And then I have this. Do I have 2/5 there? Do I have 1/2 there? Do they work together? Like that. They do not work together like that, do they? Because if I take this piece and I move it over here, it's not the same. So it doesn't work. Cool? The slices of the whole are different. So I have to do the denominator thing. So what I then have to do is I have to recognize this. 10 slices. Damn it, I didn't do enough. Yes, of course. That's the point, Amshaman. But like I said, you have to know what you're doing and why you're doing it. So we recognize if we have to illustrate fifths, x over 5 and y over 2 are different sized slices. So then we have to do the common denominator thing. Now, there's a shortcut to that. I'm sure you were all taught it. How do you find the common denominator? What's the easiest way to find it? Multiply the two together. Right? Works great in grade 4, 5, 6, 7, 8, and 9 because the numbers are all small. And the teachers aren't trying to fool you. Are there other numbers in the world? Yes. The bigger you make that denominator, the more work you have to do later on, correct? So if you learn that single step, are you able to do the work? Yes. Does it open the door for possible further errors? Yes. So it's a good thing to know exactly what you were doing. You guys were taught the shortcut of just go, shortcut. You just take, if you have something over x plus something over y, you just do x times y to get your common denominator. Correct? Denominator. So you guys here see 5 and 2. So that's 5 times 2, and your common denominator is what? 10. So you're putting 10 on the bottom of these. And then you simply remember, what did you do here? You did times 2, so you do the same thing to the top. 4 times 5 times 5, so you have 5. So you have negative 4/10 plus negative 5/10. Now, in grade 8, 4, 5, 6, 7, 8, 9, that's cool. It's no problem. After grade 9, we don't want to write it this way because it's cumbersome and math should be pretty. So once we have a common denominator, we no longer write it this way. How do we write it? Does anybody know? How would I write this instead of two separate fractions? I make it one denominator over 10, and I put my numerators on the top. Okay? That's what I want to see. Negative 9/10. Okay? You all already know this, and most of my examples are going to be so easy you can do them in your head. I want them to be that easy, because if they're so easy you can do them in your head, when it becomes more difficult, you will know the steps you need to take. Okay? And again, you won't be wasting your time trying to think of what do I need to do. So here, what is my common denominator? Would you use 72?
No.
Of course not. Why?
Because it's too much.
Because 6 works with 12. If you're not a pre-dip kid, do you have any idea how many kids I have that as soon as I've said you can just multiply the bottom two, sometimes they say, use 72! Immediately. Because they aren't thinking about what they're doing. They can't, it doesn't sit in their head that, wait a minute, 12 times 1 is 12, and 6 times 2 is 12, so I can stop at 12. Right? Okay, so we're going to use 12 because we are the smarty pantses. 12 doesn't need to change. I only need to change 6. So we know it's times 2. We know it's times 2. 2 twelfths. 2 twelfths. And what's my final answer? We know that we're going to write this as a single denominator, negative 7 plus 2. So what is it? Negative 7 twelfths. Plus 2 is negative 5 twelfths. Everybody Gouda? Okay. What about the next one? Again, can you do it in your head? Of course you can. What's the common denominator? 15. That time it worked to do the bottom two multiplied together, correct? Okay, so what does my 3/5 become? 9/15, because we're times 3. And what does my 2/3 become? 10/15, because it's times 5. Now, again, previous to now, you guys are being shown this trick to add fractions, right? Later on in math, you're going to come across things like this all the time in this course where we have to change whole expressions, not just one part of it. Okay?
Oh, okay.
Something that looks like this. Let me show it to you. Don't write this down. Don't write this down.
Oh, okay.
But is this not just a fraction plus a fraction? So if we were going to add those together, what would I need? A common denominator, just like we need with regular numbers. So we're going to use the same tactics with way more complicated math. Understand? So I don't want you falling into the trap of thinking this is where it ends. Okay? Picking up what I'm putting down? We'll be getting into that in like the 5th unit that we do. Things like this green one. Okay? Oops, I left a 2 there. So what do we really have? 9/15 plus -10/15. Now we wouldn't write it that way. 9 plus -10 over 15 is -1/15. Yes?
Yeah.
Excellent. Let us move on. I ask you, how would you guys do that? What would you do? Amsh,
I would change it into an improper.
you would change it into an improper fraction. How many people would follow his lead and change it into an improper fraction? Right? Everybody's putting their hands up. Is that okay? There's nothing wrong with that, is there? Okay, so since that's what everybody would do, that's what you're not allowed to do.
Oh.
How else could you do this? Alicia. -2 plus 3, which is what? 1. And then 1/8 plus 1/3. Is that correct?
No,
Why?
because you gotta change the denominator.
No. This is a very important math point that is often forgotten. And there's a reason I'm showing this, even though nobody likes to do it this way. There's a reason I'm showing it to you. Sam, what's wrong with that?
Because you got to use the denominator before you.
Not quite. Look at what I've written here, because this is right. What's wrong here? What's wrong with the fraction side of this?
Oh, it's not a negative.
That negative applies to both. Okay? That is key.
Oh, yeah.
Okay? Because, and this is why the number line is important to remember. There's -2. Where's -2 and 1/8? Left or right of that? Left. So we need another -8. Picking up what I'm putting down? So of course this, what's our common denominator? What's it going to be over? Does it have to be 24? Yeah. 24. So what did we do to 8? Times by 3. What did we do to 3? Times by 8. And I get -3 plus 8, which is what? 5 over 24. And then we just put it together. 1 and 5/24. Now, why do I like this better, and why should you like it better too? Sam? It's less steps. There's less possibility for making an arithmetical error. Because an error in arithmetic is not the same as an error in not knowing in method, is it? Do you understand what I'm saying? You can make a mistake with your adding or subtracting or multiplying or dividing Does that mean you don't know how to do it? No. But to a math teacher marking your work, it could mean that. Do you understand what I'm saying? Especially on a multiple choice test. Understand? So you got to be mindful of the fact that math is going to get harder and harder and harder. And the more steps you can remove by understanding what you're doing, the better off you will be when a question takes 100 steps to do. Understand? Okay, so is everybody comfortable with this?
Yeah.
Now, of course, you all said you wanted to do it this way, which is just fine. Negative 2 and 1/8 becomes what?
17 over 8, maybe.
Negative 17 over 8. And 3 and 1/3 becomes
10 over 3.
10 over 3. Okay? And then you would carry on with the same thing. Now, the problem with that, of course, is now you have to multiply 17 by 3 and 10 by 80. 10 by 8 to get 80. And then you're dealing with big numbers, and that's a pain. And then, what's the other thing your teacher always says? How do they want the answers?
Simplify.
Simplified. Simplest terms, right? Does this give us the answer in simplest terms? No. But does this?
Yeah.
Yeah. So it takes away another step. Got it?
Yeah.
Do I officially care which way you use? No. Now, because I want you guys to be aware of it, please notice that I've put a whole bunch of blanks there. Do you have to fill them all in? No. They're there to help you. They are not there to tell you what to do. If in doubt. Okay? Notice also that on your notes pages, I've left you blank space over here. Right? Right? You can work anywhere you want. Go.
How do you use the lines there?
How would you use these? Well, you would do negative 1 plus 3, and then you would do your fractions. Negative 5/16 plus 3/8. What's your common denominator? 16. So do I change the 16?
No.
Nope. So negative 1, 3. Negative 1 plus 3 is 2. Negative 5/16. It's not changing. 3/8 is becoming what?
Oh, that. Okay.
What's negative 5 plus 6?
That's positive 1.
Positive 1/16.
That's 2 and 1.
2 plus 1/16 is 2 and 1/16. Now, check if our answer is reasonable. That's about 1 1/2 plus 3 1/2, yeah? 1 1/2 plus 3 1/2 would be 2, right? Is 2 and 1/16 pretty close to 2? So are we right? Now, they suggest you check at the end. When do I suggest you check? Check at the beginning. If we were shooting arrows at a target, would we blindfold ourselves and then shoot?
Yes.
Perhaps some of the grade 9 boys in the class would run around with a bow and arrow and a blindfold. Hopefully the girls would say that's not a very intelligent thing to do. Let's see the target first, then we can blindfold ourselves and shoot. So at least we're shooting in the right direction.
Oh.
I know.
But it's still dangerous because someone could be walking out in front and you can hit your arrow.
I won't say who, but one of the teachers, when I was getting my picture taken, walked between the background and the kid getting his picture taken. So he photobombed it.
Who?
I won't say who it was, but I made a lot of fun of that person. It's like, you don't know how photographs work?
Do we know?
Never mind.
Do we know the teacher?
Zip it! All right, you guys do the next one. Go. You should already be done.
Yeah.
Everyone's cool, yes?
Yeah.
Okay. Is subtraction any different?
No.
Not when it's a regular fraction, because subtraction doesn't exist, right?
No. Yeah, because it's just adding the opposite.
Adding the opposite.
So it doesn't change.
Now, why do I go out of my way to stress that? Because too often I have kids tell me that -4 minus 5 is 1.
No, but
What is it?
it's -9.
It's -9, right? Because you're adding more negatives. Okay? All right. So what's our common denominator?
6.
6. 6 didn't change, so does 5? What does the 2 become? 2.
What is a 2? What does a 1 become?
It's 3/6.
Just give us the answer.
I do that all the time.
It's -1.
And of course, we would never leave it that way, would we?
No.
Is that correct?
Ish.
Yes. Is it right? There's a difference, right? We want that to be -1/3 or 1/2. Cool in the gang? Great. Do the next two. Should take about 2 seconds. Oh, math. And then simplify it. Oops. And then simplify it. And what do we get? -1 and 3/8 and
1 and 7/15.
7/15. I love it when kids can do math in their head. Now, mixed number form. Can you do the Can you do the mixed number form with subtraction that I use, where I take the big ones together? Does it work? It can, but it can cause you trouble. And here is what I mean. First of all, do this right now, however you would do it. The subtraction. Do that however you want. So I'm betting most of you are going to go improper fraction, right? Okay. So let's do it. Do it however you want. I'm betting that's what most of you have done.
Yup.
Most, not all, most. Something along those lines. Yeah? Sam? That's cool. What'd you do?
I did like I did this one like a 0 and then like 3, 4.
Yep. So you said this was 0 and 3/4 minus 2 and 5/8, and then you used the other method, right? So you went 0 minus 2 to get -2, correct? And then you went 3/4 minus 5/8. Then it was going to be the same, right? It was over 8, so it was 6 minus 5, which was 1/8, correct? So now you had -2 and a positive 1/8. This is why I bring the number line back to get people, Amshiman. Because if I go down to -2, but I had to go positive 1/8, so what direction is that? Back to the right. So I had to be 1/8 lower than 2, which was -1 and 7/8. Everybody cool?
Yeah.
Again, is this what you did, Alicia? You went with the big numbers? Cool. Again, do I care which way you do it? No, why? Because it's not middle school. It's not elementary school. You can do what you need to do it right. Okay? Sam?
So like so -2 and -1 right?
No, you needed to recognize this problem. That you were at -2 and then a positive 1/8. So you went on a number line, here's 0, right? You went all the way down to -2, but then you had a positive 1/8, so you had to come back that way. That's why I like to show the number line at first, okay? Because some kids like to do the big number thing, but then they forget and they say, oh, it's -2 and 1/8. But it's not, because this 1/8 is a positive 1/8. Got it? So do these next two however way you want. And then you're going to do you're going to do these two, and then you're going to work on the next thing on your outline for the rest of the block. So I'm going to do one of these with impropers, and the other one I'm going to do with the big numbers. Yep. And see how you get the same thing. Again, I don't care which one you do. Everybody good? Now, obviously, we use rational numbers all the time in our math work. You guys do the last two. I'm going to fill it in. You can mark it, make sure you've done it right. Then you go back to your outline, and you start working on lesson 2, page 111 and 119. Cool? Oops, wrong thing. How many times does 8 go into 40?
5.
How many 8s are left over?
2 and 2. 5 times
8 goes into 40.
47.
47. 8,
5
5, yeah. And then that covers 48. I have 47 8s. So there's 7 8s left over.
Oh, okay, never mind. Okay, never mind, I'm good.
Okay.
I thought it was, okay, never mind.
Okay.
I'm good.
Now, this type of question shows up all the time. I'm sure most of you do right. What math is different? Minus 43.3. To get an answer of negative 104.4. Now, look at that question and tell me if mathematically it makes sense, and then logically does it make sense. Would you say that the difference in temperature is a negative amount? Oh, crap. We'll come back to this tomorrow. See you all tomorrow. Not due. I'll give you some time tomorrow. We talked very long about weekends and things.
So, do you want Wednesday?
Do some of it. You'll have time tomorrow. Work on page 111 and 119 tonight. I'll give you a little bit of time tomorrow. Bye, guys.